So today we're talking about Unit 2, Lesson 3, the different characteristics of a graph of a polynomial. A lot of this stuff you should know already, so hopefully it's just a review. Our first important characteristic is the degree of a polynomial. The degree is the highest exponent of all the terms of the polynomial. It is literally just the whatever the highest exponent is. So, for example, a quadratic, the highest exponent is x squared. So we would say that a quadratic is a second degree polynomial. A linear equation, so when our highest exponent is x to the power of 1, we would say those are first degree polynomials. The leading coefficient, as it says here, is the coefficient of the term with the largest exponent. So whatever your largest exponent is, the term that contains that largest exponent, whatever that coefficient is, we call that the leading coefficient. The constant term, we've already talked about that previously. Constant term is the term that contains no variable, meaning it has no x in it. And the constant term is important because it tells you the value, what the y-intercept is, which is where the graph crosses the y-axis. Important thing to realize, if there is no constant term, we assume it's a 0. So if all the terms have a variable, if all the terms contain an x, then we would say that the constant term is 0. Relative maximum or minimum points. Those are just high or low points. So it's the points where the graph switches from going up to down or vice versa. So wherever it switches from increasing to decreasing or decreasing to increasing, we call those max or min points, relative maximum or minimum points. Basically the high or low points of a graph. And the last important characteristic are the X-intercepts, also known as the zeros, also known as the roots. They all mean the same thing. The X-intercepts, the zeros, the roots are where the graph crosses the x-axis. So it's kind of like the y-intercept, except with the x-axis instead of the y-axis. So our goal for today in our examples is to be able to figure out those characteristics, either without graphing or using graphing. It doesn't matter for today. So for each of the following polynomials, we're going to find the degree, the leading coefficient, the y-intercept, the x-intercepts, if there are any relative max or min points. So let's take a look at the first one. The first one is x to the fifth minus 4x cubed plus 5x plus 2. So the degree, remember, is the highest exponent. All right, in this case, the highest exponent, let me change it to a different color. The highest exponent looks to be x to the fifth here. So my degree is 5. Okay, and number 2, x squared minus 6x plus 11. Looks like my highest exponent is x squared. So we would say that number 2 has a degree of 2. And then number 3, 2x minus 5, even though there's no exponent here, there's only one term with an x, we would say that that is 2x to the power of 1. So we would say that number 3 has a degree of 1. Okay. The leading coefficient. Leading coefficient, the coefficient of the term with the largest exponent. So what we're first going to do is I'm going to, again, use a different color. I'm going to circle the term that has the largest exponent. So that would be this one, and this one. Those terms have the largest exponents. Okay, whatever that coefficient is what we call the leading coefficient. So in number 1, there's no coefficient there, so we would assume that that leading coefficient is a 1. Same thing with number 2. The term with the largest exponent is just x squared. That's really a 1x squared. And in number 3, we would say the leading coefficient is 2. Okay, so that's the leading coefficient. The y-intercept, okay, the y-intercept, okay, that's right here, okay. The y-intercept is the constant term, okay, the term with no variable. The value of the constant term tells you the y-intercept. So what I'm going to do is, again, using a different color, I'm going to circle the constant term of each of these polynomials. Okay. The value of the constant term tells you the value of the y-intercept. So the y-intercept for number 1 is 2. The y-intercept for number 2 is 11. And the y-intercept for number 3 is -5. Okay. X-intercepts. Where the graph crosses the x-axis. Okay, now we can find those values if the polynomials are in factored form. In this case, the polynomials are not in factored form, so we are going to simply use Desmos. So for number 1, let's put number 1 into Desmos. Okay, and if I look at number 1 here, I can notice that there are 2 x-intercepts. Okay, so there's an x-intercept at -1, and there's an x-intercept at -1.585. So -1 and -1.585. Okay. If I look at the graph of number 2, here's the graph of number 2, x squared minus 6x plus 11. Okay, if I look here, it looks like there are 2 x-intercepts. Okay, and did I type this in wrong? I did type it in wrong. That should be plus 11. Okay. So x squared minus 6x plus 11. And if I put that in, notice there are none. There are no x-intercepts. It never actually crosses the x-axis. It stays completely above, and that is okay. So in this case, there are none. No x-intercepts. And then number 3, if I look at the graph of number 3, 2x minus 5, it looks like there's only 1 x-intercept at 2.5. So the x-intercept here will be at 2.5. Lastly, any relative max or min points. So that's going to be any high or low points wherever the graph changes from increasing to decreasing or vice versa. So again, we have to look at the graph. So if I look at, for example, number 1 here, I see 2 maximum points and I see 2 minimum points. Okay, so there's a maximum point. Let me write these down. So max at -1.365 and 0.609. Okay. There's another maximum point up here, so 0.733 and 4.301. Okay. So those are my maximum points. Minimum points, there's one down here, -0.733 and -0.301. Okay. And then there's one up here, a minimum point up here at 1.365. Whoops. And 3.391. Okay. All right, so I have two in this number one. There are actually two maximum points and two minimum points. In number two is a parabola because it's a quadratic. So in this case, it's a U-shaped, and you can see it looks like there's only one. In this case, there's a minimum point down here at 3, 2. There's only one. So there are no maximum points. There's a minimum point at 3, 2. So no maximum points, but there is a minimum point at 3, 2. Okay, number 3 is interesting because number 3 is linear. Okay, if I keep zooming out, it's just a straight line. All right, so if we think about it, is it possible for a straight line to have a maximum or minimum point? The answer is, of course, no. So in this particular case, there are none. Well, what's going on here? Oh, that's what's happening. So in this case, number 3, there are no maximum or minimum points because it's linear in nature. If we take a quick look at your cool down for tonight, your cool down is just going to be 3 more examples similar to what I just did, and you're going to identify all those characteristics that I just did: the degree, leading coefficient, x-intercepts, y-intercepts, any relative max or min points.